Hello and welcome to our demo video. The client requires our smart farming system project to perform two major functions. Function number one, to count the number of days that the plant has been planted inside the greenhouse. There will be an LED light that will indicate the day that the plant has been inside of the greenhouse. On day one, it will flash white. On day two, day three and day four, it will flash green. On day five and day six, it will flash orange. And from day seven onwards, it will flash red. And once the plant has been harvested, the counter will be reset back to day one and the LED light will switch back to white. Function number two, we need to add a display to the smart farming system, and the display will show us the soil moisture, the soil temperature, and the soil pH. These three measurements, they have three separate sensors and they will be connected to one input port at the display. And to implement this system, we are going to use a counter, a decoder, and a multiplexer. Okay, so let's start with the counter. We are using a synchronous counter for this to count from day 1 to day 7. And all the workings and our calculations, including the state diagrams and K-maps, are included in the written report. So let's just skip to the circuit over here. We will be using T flip-flops and also several logic gates to implement our counter. Our counter also has something different, which is a button and also a NAND gate over here that allows us to reset from day 7 to day 1. After the plant has been harvested.
Okay, so now here's the simulation for the counter that has been mentioned before. As you can see, this is the reset circuit, this is the reset button. These are the flip-flops where FFO represents LSB and FF2 represents MSB. Now we're going to simulate it with the frequency of 2 Hz and we're going to have ticks enabled. So this is the start of simulation. So as we can see, it starts with 1, 2, 3, 4, 5, 6, and 7, which in binary. As you can see, it will not change until I press the button, and it will reset back to 1, 2, 3, and so on. So that's the end of the simulation.
Subsequently, our system also requires a 3 to 8 line decoder because from the counter, we are actually having 3 bit binary numbers. But most importantly, how does the decoder work? As you can see, here is the overall circuit for the decoder. The Q2, Q1, and Q0, we actually got it from the output terminals of the counter. And right now, in this case, they are acting as the input terminals for the decoder. And the input signals brought by them will ultimately decide which output terminals of the decoder will be activated. For example, if the input signals are 111, that means M7 will be activated, and the red LED and the speaker will eventually be turned on. And why not let us stimulate it?
And now here's the simulation of the decoder. As we can see, this is decoder of 3 to 8 where we have 3 inputs and then we have 8 outputs from at0 to at7. So now when we have 0, 0, 0, nothing will light up. And then we have 1, the white light LED lights up. And 2, 3, and 4, the green LED lights up. And then for 5 and 6, the orange lights up. And then when it turns to 7, the red lights up. So this is the end of the simulation. After looking at both of the circuits, we can combine both of the circuits. As we can see here, this is the counter circuit and this is the decoder circuit. And then when we start to stimulate it with ticks enabled at the same frequency of 2 Hz, it will gonna light up as what we intended. White, green for the 3 days, 2 days for the orange, and then red. And it will stop until I press the reset button. And then we'll light up the white and it will follow in the loop. That's all for the simulation for this circuit.
Next, to connect the 3 sensors to one input port such that each sensors can be read individually, we are using a multiplexer. As you can see, the 3 sensors are connected to a 4-to-1 multiplexer with a donkey, and we can actually select whatever sensor that we want to read using the selection line AB. Let's start the stimulation.
Now we're going to stimulate the sensor circuit. As we can see, we have 3 inputs which represent 3 different sensors, which is the moisture, the pH, and the temperature. We use 4x1 multiplexer to get a single output, and this is a selector. So when the selector is at 0, 0, the output we're going to follow at 0. No matter what is the input for S1 and S2, it will always follow at 0. As for selector become 1, the output follows S1. And then when the selector becomes 1, 0, which is still in binary, it will follow S2. And that is all for the simulation of this circuit.
That's it for our demo video. Thanks for listening and watching. Hopefully you can understand how our smart farming system works, and have a nice day. Thank you.